Hello again, and welcome to the second part of this lecture, which is the physics of manometer. Manometer is a device or a simple instrument for comparing pressure, usually by the differencing in height of the two liquid of column. So you have this liquid, okay? You have two columns, this column and this column. By comparing between the length, you will measuring the pressure between them, okay? And you will understand how to do it. We have three types of manometer. We have type case number one. And in this figure, we see that is a U shape, okay, filled with the liquid. There is open in both sides, okay, and that means the atmospheric pressure is pushing on the same amount in the both sides. Note that the both ends of the tube are open to the atmosphere, and thus both points A and B are atmospheric pressure. The 2 points also have the same vertical height. So that means the pressure on that side the same as the pressure on that side, because the height of the column here is the same of the height of the column. See here, see the empty space here is the same as empty space here. That means the pressure here is the same as the pressure here. Okay. And this is the case one. The case two, now we imagine that there is a sample of gas in the closed end of the tube. See, this one is open to the atmosphere. Whenever it's open to the atmosphere pressure, that it's open to be to the atmosphere pressure. The second one is closed, but not just closed. We will suppose there is like a gas, a sample of gas. So let me show it here. So this is, let's say, a sample of gas here, pushing gas on that side. Okay, what you will expect? We will expect that the point A is atmospheric pressure. This is atmospheric pressure. Okay. The point C is the pressure of the gas in the closed end of the tube. So here is the the point C. Now we have point C is the pressure where in the closed area. The point B has a pressure greater than the atmospheric pressure. Okay. So the point B is the point that the pressure here on that side is bigger than the atmospheric pressure. See, the B always it will be where it will be in front of C. Okay, so this amount of space here, this is the difference between the pressure in this area, in the open area and in the closed area. So in this case, the pressure of the gas that is trapped in the closed end of the tube is greater than atmospheric pressure. See, the height of the column here is what? Is this amount, while the height of the column here is this amount h. Okay, so if I am saying it, I will say h for C is bigger than h for A. Okay, h for C is bigger than h of A, and this is the case two of the manometer. Okay, in case three, now we suppose the one of them is open, the second one is just closed without any let's say any gas here. So what you're supposed to say to see that atmospheric pressure will be pushed high on that side than the other side. So see the height of the column here, if I just draw it for you, the height of the column here, this is h, see? Okay, see? Well, the h here is what? Here. So the difference between h, this is hc, and this is ha. Okay, so the difference between them will give you what? Will give you the height of the column here. This is h, which is coming from HA minus HC. Okay, we conclude that the pressure at C then is less than the atmospheric pressure by the amount of the pressure applied for the liquid of column. So this is the difference between them. Okay, so now the pressure here is bigger than the pressure, or the pressure on the here on that side, the open side, is bigger than the pressure on the other side. Okay, now what do we have? And this is the end of part 2 of lecture 3. Thank you very much.